Hey everybody, how are you? Jim DePalma here, and thanks for joining us for a system approach to venting condensing boilers. I'm sorry, we're having way too much fun before we even get started, so we've been laughing, we're having a good time. All right, so with me today answering questions as part of today is Johnny Resso. So if you have any questions, you're going to type them in. John will answer them and ask them live. Christiane Levine and Eric Hayes from marketing are back there running the whole program. Let's do some housekeeping first. On your screen, you can click on where it says webcams. Click the down arrow and click left. That'll put me on the left-hand side of your screen, and then you'll have the PowerPoint on the right-hand side. In the middle there, you'll see three little hash marks in between the two screens, and you can expand and contract the screen so you can view this how you'd like. Also on your screen in the upper right hand corner, you're going to see a pane. You'll see an arrow and a red box. If you click on that and open up the pane, excuse me, and scroll down, you'll see where questions are, and that's where you can type in any questions that you'd have, and we'll answer you back and forth either that way and live. Okay? Part of your handout today, or I think it might have been in a separate email, is a Centrotherm catalog. So this class today will be using Centrotherm as the reference. All right. All right, so let's get going. So a system approach to venting condensing boilers. I have to tell you, I learned a tremendous amount doing research for this type of class. Relatively new product for us, and myself and the rest of the guys in the CSG group are out in the field on a lot of jobs. So we see a lot of different appliances installed, whether they're tankless water heaters or they're condensing boilers, non-condensing product. We see a lot of installs, and we'll see some really good piping. But then venting seems to be an afterthought. And one of the things that we preach here is always making sure we have the right appliance for the right application. What we're going to preach today in this venting class is making sure we have the right material for the right application. Very interesting part of this learning process for me was when it comes to plastic venting, where do you get your directions from? And through reading any manuals and any codes, it's based on what the boiler manufacturer specifies. So you have to follow the boiler manufacturer's instructions. We're the NTI reps. I have NTI boiler right here. The manual's right here. There's 11 pages on venting in there. So every manufacturer is going to have multiple pages for you to read to make sure you're going to install your venting material that they approve of correctly. So one of the things that really struck me in researching this again was one phrase, that venting is a safety system. It's not something that we what's the word I'm looking for? We try to jam in just to make everything work and get off the job. It's really a safety system. So when myself and the rest of the guys show up on a job to help you maybe lay out the job, and we know we're going to be dealing with condensing product, the first things we're looking for is how we're going to vent this. Very, very important. And sometimes that takes our condensing product out of the install because there's really no proper way to vent it. So we always want to make sure that we're treating venting as a safety system. And this is really what we're going to be talking about today. So topics of discussion, as you can see on the screen, we're going to talk about the different categories. So we'll go over natural draft, make sure everybody is comfortable with what that is, and things you should be looking for when you're changing out any type of appliance that's going to be using gas and using a chimney. All right, so any of the issues that can happen in that regard. We'll go over what category 2, 3, and 4 heating appliances are. We'll go over materials that you are allowed to use based on manufacturer's specs. But it's very important that you follow manufacturer's specs as you see as we go along. Vent design and its impact on performance. What's actually happening when we're burning gas, right? Or fuel oil or propane, right? What happens when we're burning it? What is being produced? And what can happen when we put these type of appliances in and maybe don't maintain them? We're at the point now in since 2002, when condensing product has come out as standard equipment, the Munchkin, Wal-McLean Ultra, and they're hitting their 15, 20-year marks. So these appliances are going to be replaced soon. If not, it's already been happening. And if they haven't been maintained, it affected the venting material that was previously installed. So if you're just going to adapt to what's there, you may be surprised. You may have to inspect that. And we'll show you where you can find some more information when it comes to codes and standards. We're not the code police. We don't profess to be, but we'll show you where you can get more information when it comes to codes. All right, so a smart person said to me, Jim, when you start this presentation, you should start off with history. And I agree in a big way. So how did we get to this point? How did we get to this point where PVC, CPVC, AL294C, and polypropylene venting can be used for our appliances? So if you look, back in the day when I started on this chart here, back in the day, 30 years ago, we were just starting to get into pushing appliances to an 80% efficiency to an 82% efficiency. And that required all the boiler manufacturers to make a lot of changes to their product design. At that time, we were selling and repping Hydrotherm HC boilers, which in the North Jersey metro area was a very popular boiler. To make 82% efficiency, their vent hood had to get really tall. So residentially, that created a problem. Did we have enough space? Commercially, we were selling a lot of MR boiler systems, multiple cast iron modules under one jacket, and the same thing had to happen. Those vent hoods had to get taller than they were common vented with proper pitch to get into the chimney. But as they got taller, we were running out of ceiling space, so those vent hoods got chopped. So a lot of those boilers were being installed with improper venting. And then as the efficiency got higher and higher, those designs were no longer viable for that company. So as we started to transition now from 82 to that 83, 84, 85, we had the Hydrotherm Pulse boiler, which was an 82, 90% condensing boiler. But we found the majority of them never condensed a day in their life because they were firing at high temperature. Then as we started to get into more efficiency, in that late 2000s, we had AL294C as your product as a reference, and then PVC was also being recommended for use. But very important that you follow the boiler's install specifications to make sure that you were going to stay within the temperature range. Okay, if you follow their recommendations, they're telling you that the temperature of the vent couldn't exceed 140 degrees. Now, in doing research, there's no standard from the PVC manufacturers for a temperature because PVC is designed for water. It's not designed for venting. But the boiler manufacturers will say in their install guide, as long as your stack temperature is not going to be above 140, that product will work. But how does that affect your system design? Well, if you've been to our hydronic classes, we tell you how a condensing boiler is going to condense. It's based on return water temperature being 130 degrees or less. But the interesting thing is your supply water temperature, whatever that number is, your flue gas temperatures will be 20 degrees higher. So one of the things we like to talk about is even if I'm replacing a cast iron boiler and I do the heat loss, which is what we promote, and I find that the boiler was too big and all the baseboard was oversized, and I can get away with using 150 degree supply water temperature to heat my home with a condensing boiler, and using my delta T circulators that Taco has to maintain that 20 degree delta, I can have that return water temperature of 130 degrees. But now my flue gas temperature, if I'm supplying 150, right, very close to the boiler and through the venting, is going to be about 170 degrees, which takes us technically out of that range of 140 degrees for PVC pipe. So it's not the proper material. And I think a majority of us out there don't realize that. So what we're going to talk about today is making sure everybody understands what's available, why it's available, and how to pick the proper materials. Okay? So going forward, what happens when we start burning gas? Well, as it shows you on the PowerPoint here, if I burn 1 cubic foot of natural gas, it'll produce 37.5 gas volume, okay? And in that flue gas is moisture. If I keep the flue gas temperatures nice and high, that moisture will never turn back into water, won't condensate, won't cause us any problems. But what happens when we're burning gas is we have to make sure that our vent is properly sized. If it's too big or too small, now that volume of flue gas that we've now created won't be able to vent properly. So that 37.5 cubic feet of flue gas is going to create water vapor. And again, we have to keep the flue gas temperatures high. So what happens if we don't? Well, then that gas, which we cannot see, all right? So what you're used to seeing coming out of the chimney or maybe out of the sidewall vent, the white plume, is technically not gas anymore. It's converted to vapor. It's cooled down at that point. So if we cool it down to that point, you see the white plume, it's vapor. We cool it down even more, it becomes now water, and that's the condensate. So that 1 cubic foot of burned gas produces that 37.5 volume of flue gas products. It also can create 2 cubic feet of water vapor. Wait, there's more. That'll equate to 1 gallon of condensate. So if you follow what's on the screen there, 100,000 BTUs over an hour's time will produce 1 gallon of condensate. Now, the world of condensing product, that's a good thing because a gallon of condensate is 8,080 BTUs that we want to reabsorb back into the appliance. That's what we want to have happen. But that condensate is acidic, very aggressive. And if we're not using the proper materials for venting, we can break down the venting material. We can damage the appliance if the appliance isn't capable of handling that, if the heat exchanger can't handle that aggressiveness of the condensate. So we really have to be aware of things like this. If we were having a condensation problem in a standard chimney, you'll see things like this. That condensation starts to break down that clay liner, breaks down the mortar. We've got now moisture breaking down the chimney, damaging the home. So you can see clearly here, if I show up to a job and I want to use that vent in that chimney, maybe for a chase, and I see something like this, I'm going to have to inspect that flue and make sure there's no collapse, no damage. All right. Further pictures here show you how we can now start to even damage the walls inside the home. So this is a problem. All right. We do have to be very aware of this. So let's go over appliance categories. Let's make sure everybody understands the different categories that we have. We have category 1, 2, 3, and 4. Category 1 is your natural draft. That's going to cover appliances that are less than 84% efficient. That's your standard high temperature cast iron boiler. All right. Standard cast iron boiler today you're going to buy is going to be 82% efficient. This is your standard natural draft type of system. Okay. Category 2s, they operate at a negative vent pressure. All right, but they can operate if flue gas starts to condense. All right, the appliance can handle the condensation, but they're going to use a fan to move that hot gas through a secondary heat exchanger, but that won't create a positive pressure at the vent. It's still a negative natural draft. What I failed to mention was on the natural draft category 1, your flue gas temperatures are higher than 140 degrees. Category 2, your flue gas temperatures are less than 140 degrees. Category 3 is non-condensing, and they operate with an even stronger fan that can handle higher temperatures, all right? And that will create a positive pressure at the venting itself. So that could be a non-condensing, wall-hung, tankless water heater, things of that nature, and there's plenty of those out there. In category 4, which is going to be our main focus today, this is a positive vent pressure system, all right? And we want this product, if we want the high efficiencies, to operate in the condensing mode. So again, in order for that to happen, return water temperature's got to be 130 degrees or less to cool down those flue gas temperatures so we can revert back from a gas to a vapor, back to a liquid, reabsorb that late heat energy back into the appliance. All right, so we're going to give you a bunch of definitions today. So here's the definition for natural draft. And as it states here, natural draft is produced by the difference in the weight of column of flue gases within the chimney or vent and the corresponding column of air of equal dimension outside the chimney vent. So as long as my flue gas temperature is nice and high, nice and hot, it's going to be lighter than air, we should get our draft, okay? What's critical about that is where that vent is. Is that vent in an area where the surrounding ambient air temperature has the potential of cooling down the flue gas temperatures, right? So those pictures I showed you earlier, that's probably what was happening, causing the condensate damaging the chimneys. So whether it's a chimney or it's a metal vent that's running through the structure, right? If the surrounding air temperature could be cool enough to cool down those flue gas temperatures, it's going to affect the materials that we use for our venting. Mid-efficiency heating appliances. So here's some definitions there. Forced draft, that's the blower before combustion process. Induced, the blowers after the combustion process. But that still does not create a positive pressure. It's still a negative pressure, and that's removed by natural draft. Those are your standard two-pipe water heaters, right? Induced draft water heaters. That's what that type of appliance would be. All right. So what we're talking about here is as long as flue gas temperatures are nice and high temperature, we'll keep that gas from changing from gas to a liquid. So 80%, 82%, that'll keep that from happening. That's what this chart is showing you here. But what happens when the flue gas temperatures start to cool? So if they get down to 128 degrees, I start to produce excess combustion air volume. You can see 40% as we get even 2 degrees less, 50%. We get even cooler, it grows tremendously. And we have to take care of that excess combustion air. All right, so what does that mean? What does that mean when I got people running around me, so they've got interesting things happening. So what does that mean when it comes to our venting, and how's it going to impact system performance? So obviously material that we're using, we have to be cognizant of this, so we pick the proper material, okay? We have to make sure we're always sizing the venting properly to handle this volume of flue gas. Where it says number of cold starts, duration of wet time, number of wet dry cycles, what that's talking about is when you install an appliance for the first time. Now let's use a water heater for an example, and you fill up that water heater with 50-degree water. I fire the burner. You may hear sizzling at the burner, and people think that the tank's leaking. It's not leaking, it's condensing. So until the tank gets up to temperature and until the venting gets up to temperature, we may be condensing. So on a cold start, that'll happen. That will happen every winter at the beginning of the heating season if your boiler's been off all summer. So the problem becomes if this is something that occurs on a frequent basis. All right, so normally residentially that won't be, but that's what that is referring to. Climate, altitude, well, the further north you go, we have longer winter, colder ambient air. So again, how the vent is run, is it in a conditioned space, unconditioned space? Could that ambient air temperature affect the flue gas temperature? Your installation techniques are very important. We do have to follow manufacturer spec, but also we have to make sure that if we're going to have some maybe flat runs in our venting before we can get some pitch, and there's a possibility of condensate, we do have to have drains installed to make sure that we can get rid of that condensate. We can't have any puddling in the venting because that's going to stop flue gas from moving out, and we can create a very dangerous situation. And the last thing, contaminates in the combustion air. Flue gas, when we do condense, becomes very aggressive. That condensate is a hydrochloric acid, all right? So it can eat through venting, and eat through heat exchangers. We want to make sure that the appliance and the venting material that we use can handle that. All right, next, when we're designing our venting systems, we want to make sure that we are doing it properly. We want to make sure we have the lowest resistance to the flue gas. Make it easy, right? Not a lot of elbows, not a lot of T's. All right, we want to make sure it's simple and easy for the gas to get out. No hangups. We want to keep the mass of the flue venting system as small as possible so it can quickly warm up. All right. Again, that insulating properties. Where am I running the vent? Can the gas temperatures be compromised because of cold surrounding ambient air temperature? We want to make sure we size the vent properly per manufacturer's spec. And obviously, we must follow local code. Local code will override everything I'm talking about, but they will defer to manufacturer spec. So I'm talking about manufacturer spec, where the NTI rep in their manual, there's 11 pages devoted to venting. So you're follow their spec, the vent size, length of run, etc. Okay. So types of vents for natural draft. Well, that could be a masonry chimney, as you can see on this slide. If the chimney's been compromised, we may do a liner. So we can use aluminum for natural gas. Stainless steel will work for all fuels. And we can use polypropylene for gas, but we have temperature limitations. We cannot go above 230 degrees with a polypro liner. B vents, pipe within a pipe. For natural gas, that's recommended for category 1 appliances. L vent is another pipe within a pipe, but now that inner pipe is not aluminum, it is stainless, and that is recommended for oil-fired appliances. So another definition here for a masonry chimney. If you want more information on this for category 1, you can go to the NFPA 211 for specific construction details. So if you're ever not sure, all right, this is where you can go to get that information, NFPA 211 for those details. If I'm lining the chimney, it will be determined based on the fuel gas or the fuel, I'm sorry, that you're using. So again, we can use stainless on all of them, but if we're doing natural gas, we can do aluminum, all right? But again, if it's going to be poly, we have to make sure that we're under 230 degree flue gas temperature. More information when it comes to relining a chimney. When it comes to oil, you want to refer to NFPA 31 Appendix E. And what I find interesting about this is it lists, let me see here, that the liner should be needed to reduce transient low draft during startup and acid water condensation during operation. So no excessive elbows, no excessive bends. And if condensation is being produced, the liner has to be able to accept that, not break down. All right. More requirements if you want for relining for oil. Again, NFPA 316-6.6. All right. The material also has to be approved for corrosion, softening, and cracking from flue gas temperatures. All right. So very important. So if you want information on relining, NFPA 31 is where you're going to go. When it comes to flexible liner rules, we want to treat it like if it was double wall pipe. Straight as possible is the best. A few bends is fine. A lot of bends is not fine. We do not want that. All right. When we are using a flexible liner, we do have to reduce its capacity by 20% for gas. 15% of the fuel oil is being used. All right. Again, we want to maintain the straightest line possible. If I go past anything that would resemble a 90 degree, so if we go have two 90-degree bends in this flexible liner, if I have to do another one, we take an additional 10% reduction for that liner. So really with the liners, we want to keep the elbows or 90-degree bends to the lowest amounts possible and keep that liner as straight as possible. All right. So B vent, if you're not sure what B vent is, because there are a lot of new people coming into the industry, it's a pipe within a pipe. So our flue gas is going through the inner pipe, that is aluminum. Basically for natural gas, that would be aluminum. I've got an insulating airspace, as you can see on the slide, and I got a galvanized steel outer pipe. That insulating airspace is important because that's what's going to keep the flue gas from condensing if I'm surrounded by cold ambient air temperature. If oil is going to be my fuel of choice, we want to go with an L vent, same style, but the inner pipe is now stainless steel. So that's what we want to use if oil is going to be our fuel of choice in this application. One thing I found very interesting here is what happens when we start up our system. It's going to take 309 BTUs to heat up that masonry chimney, that clay liner, from 0 to 120 degrees. If I use a double wall pipe, a B-vent style pipe, within the first 10 feet, it's only going to take 90 BTUs to get that liner from 0 to 120 degree temperature. So we're showing you this because, again, if I'm running that pipe, all right, it doesn't have to be a chimney. It could be a standard steel pipe, vent that somebody has on the side of the house or running through the house. If ambient air temperature could be an issue, we want to make sure it's a double wall pipe. So this is very interesting too. Here's another definition, but what we're showing you here is very common. We have two appliances, common venting, and that furnace or boiler doesn't operate all year long, but the water heater does. So now I'm in a situation where that boiler or furnace is not going to be firing. It's the summertime, and my 45,000 BTU water heater is going to be firing. So at the base of that common flue, I'll have 355 degree flue gas temperature, which is fine. But now I have the potential, since it's single wall, if ambient air temperature is cool enough, we can cool down the flue gas temperature. So at the top of the venting, I could be at 94 degrees, which now is going to produce condensate. That's going to damage the liner and can damage the appliance that's not even running. So if that could possibly happen, we want to take and use a double wall pipe. Because of that insulating air property around the flue gas, the same situation, I'll have 355 degrees entering the flue, the main vent, I should say, but at the top, it'll be much hotter. I should be around 195 degrees. I won't condensate, won't damage the liner, won't damage the non-working appliance. Johnny, any questions so far? I've been like a run-on sentence since I started.
We're looking good.
Looking good?
Yep.
All right.
Couple of questions and answered them, and yeah, keep going.
All right, very good. So again, just to drive this point home, if my venting could be in a situation where the ambient air temperature around it could cool it down, a double wall vent is what you're going to want to use. All right. Low probability condensing happening, or if it's single wall, that gets much higher. When we are common venting in a category 1, we want to keep the main vent, the common vent, as short as possible. This way it can heat up as quickly as possible. We also want to have the least amount of elbows and or 45s. You want to make it very easy for the flue gas temperature to be able to run through that piping and get to the common vent. Okay, so if you are in a boiler room, you want to use as much ceiling height as possible. You want to keep that T, where the two appliances are coming together, as high as possible. Again, our main vent will be as short as possible at that point, and we can get that up to temperature much quickly. We want to avoid trying to have these elbows low and a lot of elbows, and we want to keep that T as high as possible. That's going to make our vent work in our favor. So this slide here shows you what's preferred, what's acceptable. Now you can see the difference between preferred and acceptable is a couple of extra elbows that we've added right at the main appliance. And we've also added now a couple of 45s in the main vent. Or on the right-hand side is I've got now too many elbows. I got an elbow at the water heater. I got 2 elbows down at the main appliance, and then 2 elbows in the primary vent. All right. Based on that appliance and that manufacturer of the venting material, that elbow could be the equivalent of 5 feet. And we don't want to do that. We don't want to have too many of them in there because that'll slow down the flue gas from rising up that vent. Another piece of good information is making sure we get proper pitch when we're doing a category 1. So I want you to remember this. It's a 1-to-1 ratio. So in this example here, we're showing you on the horizontal, if it's 30 feet, then I need 30 feet on the vertical side. All right, so it's a 1-to-1. So if it was 10, I need 10 on both sides. If it was 20, 20 and 20, that's what we want to attain. If we want to make sure that we're figuring out proper pitch, whatever your horizontal run is going to be, multiply that by 0.25, and that will give you your 1/4 of an inch per foot pitch. So this example is showing you 16 feet times 0.25. It should be a 4-inch difference from the start of that horizontal run. All right, A lot of information for a category 1. But even here, we see some interesting installs out there in the field. So on this slide here, you can see what we prefer, what the manufacturers prefer. And I'm not using hard elbows there. We're using 45s. We could use a 90 and 1T. We start adding more elbows, we're going to start to run into problems. So again, this is right out of standard install guides and codes. We want to make sure that we're 3 feet once we do come through the roof to the top of the vent, 2 feet away from the actual peak of the roof to the top of the vent, and 10 feet away from the peak of the roof to the top of the vent. That's why sometimes you see some odd looking venting coming off the side of homes. They have to stay within these standards. So that's a lot of information for category 1. So now we're going to start getting more into the condensing side of things. So to make sure everybody's up to speed, a condensing appliance, how does it condense? How does it operate? We've got a fan, we've got 2 pipes. What's going on here? So we're using a fan to bring in outdoor air for combustion. Very rarely will you have enough room in somebody's home in the basement to have enough combustion air to use room air. You're going to use outdoor air. And we're going to use a fan after combustion, all right, to blow the products of combustion, get your gas out the side of the house, all right? What's happening is we want the return water temperature, again, to be below 130 degrees, which will cool the flue gas now back from a gas into a liquid. The appliance's heat exchanger can reabsorb that latent heat energy back into the appliance. That's how we get nice high efficiencies. That's how you get to the 90, 95%. Okay? If you put in a condensing product, a condensing boiler, and you high fire it all the time, and you use PVC venting as your vent material because the manufacturer approved it, it's the wrong application because your flue gas temperature must be 140 or below. If I'm making 180 degrees out of that condensing boiler, that means my flue gas temperatures are easily at 200 or higher. Wrong application, gentlemen. And we see that a lot. We'll see that a lot, especially when the condensing boiler gets put in, outdoor reset was installed, and the homeowner doesn't feel the same comfort as they did with their standard cast iron boiler that they had. So we see this commonly where the contractor will go back and just disable the outdoor reset because that must be the problem, right? And they'll take it out and the boiler doesn't know outdoor temperature and it's just going to high fire. Yet it's still vented in PVC. Wrong material, gentlemen, wrong material. Remember, venting is a safety system. It's not something we do as an afterthought. So I want you to think hard about that if you've walked in on jobs and that's what you're noticing. So if you're serving that appliance and that's what's happening, that's really a dangerous situation that should be addressed. I kind of spoke about this a little bit earlier, category 3 positive non-condensing gas-fired boiler or tankless water heater. That's what we'll kind of see around in this area. These are high temperature, they're not condensing product. So again, a PVC vent is not acceptable for this type of application. It's going to have to be a metal vent, or if we're going to be below 230, you can use a polypropylene type of vent. But we cannot use PVC in this type of application, okay? To show you other types of condensing product, here's a fire tube heat exchanger, which is very popular with a lot of boiler manufacturers. What's happening here, you'll see you'll see the burner at the top of this heat exchanger, and the tubes that are going down, that's where the flue gas will be driven down, they're surrounded by water. That's how we're heating water to heat the home. At the bottom is where the return is. And again, nice cold return water temperature cools down the flue gas. We make that condensation. The material of this heat exchanger is generally a stainless titanium type of material, so it can accept that corrosive condensate. One of the important things for you as the installer is you do have to take that condensate and neutralize it. It's very aggressive. If I just dump it down a floor drain that's in the home, and that's probably cast iron pipe, you will rot that out in no time. That's how aggressive it is. So we have to make sure our venting material can handle that. All right? I know I'm hammering this home, but we want to make sure everybody really understands. So here's another, here's a little video to show you what a water tube heat exchanger looks like and actually what's happening within that boiler. Okay, seems to be a little slow on the uptake here, but what you're going to see as it turns is where the burner will be located and where it's firing and how, yeah, right there. So now we're going to see where the burner is going to be located. You're going to see where it's firing at the back here. That's the return side. That's the refractory plate. But on this side here is where the return water is going to be coming and cooling down those flue gas temperatures. And as they collect at the top of the boiler and vent out, right, that's where we're going to be retaining that latent heat energy. So again, the heat exchanger has to be able to handle the corrosive condensate, as does the venting. So a definition here, another definition for you for a direct vent appliance. This is an appliance and the venting material and the vent cap basically that are supplied by the manufacturer. So you'll see this more commonly in a lot of direct vent or two pipe water heater type of applications. This is supplied by the manufacturer, and we're going to be using outdoor air for combustion, and then we'll vent the products of combustion out the side also. So you use all that material from that appliance manufacturer. So a definition for mechanical draft venting, because we'll use these words back and forth and sometimes people get confused. So draft produced by a fan, and the fan is located before combustion, that's going to push the flue gas temperatures through the chimney or the vent. All right. If it's after, it's going to pull it through. So that is now a forced draft fan. I'm sorry, when we're pushing through, it's forced draft. When we're pulling through, the draft is induced. Again, you'll see a lot of that in water heaters. But we're concentrating today on category 4. So this is what a positive pressure vent definition is. We're showing you category 3 and 4 appliances. This has to be a design system that is gas and water tight, up to 6 inches water column. And if it's going to be a system, and since we're talking about a system, it should have a UL specification of 1738. So the Centrotherm product we're talking today is an approved UL 1738 venting system. It's not parts and pieces of other product that we use for water. This is strictly for venting. This is what you want to use for condensing product. We should always consider local code. That local code overrides everything we're talking about today, but they defer to manufacturer spec. That's going to be in your boiler install manual. Like I told you, the NTI that I got back here, 11 pages dedicated to venting. You must read it. You must follow what they're talking about. We want to make sure that we have the lowest resistance to the gas, flue gas through the venting, not a lot of elbows or T's. Keep the volume of your venting as low as possible, so for quick warm up. Be aware if ambient air temperature can turn that flue gas back into a condensate. If we don't want that, we want to make sure that we have proper insulating around it. That doesn't mean you're putting a blanket on it. It's going to be a double wall. And obviously make sure we have the correct
You're back.
We're back. All right.
But he's back on us.
It's back on us. We're looking at Chris.
Okay, let's switch the camera now.
Done.
Okay. DVF.
I can't because the webinar started before the camera was turned on.
Okay.
I would have to shut it down.
Don't shut it down.
Switch back the camera.
Hi, Robbie.
Howdy.
Howdy.
Type of message. Oh.
It's only recognizing the DRD
Okay.
I see me now.
sound.
That sounds good. All right, everybody. All right, we're back. Things happen. So here we go. So if you want more information when it comes to code considerations, one reference code, section 502.1. Okay, and it talks about the different categories and venting material that's allowed. For category 4, what's very interesting is what it states here. Is category 4 appliances shall not be required to be listed and labeled where such vents are specified by the appliance manufacturer and are installed in accordance with the appliance manufacturer's installation instructions. What does that mean, guys? The boiler manufacturer, right, in his install manual under venting, that's what you're supposed to follow. So the code's not calling out what to do. It's telling you to follow manufacturer's spec. All right. All right, we're good. All right, going forward, here's another excerpt from the International Fuel Gas Code, section 12.4.5.2. Talks about making sure that your vents, your connections are proper. Make sure that you can't have any of them above the ceiling. So references you have to follow here, that your sealant, your cement, your PVC type of cement, CPVC type of cement has to be approved for high temperature. Things you have to be aware of there, okay? And making sure that your vents, again, are within a non-concealed space. I love this one from New York City Fuel Gas Code, where it says PVC shall not be permitted. No chance, you're done, you're out. All right, so you're gonna have to follow that code in New York City, okay? Another interesting thing I found, and this may wake up a lot of us here today, is if I am using glycol in my system, and that is on the boiler side, not just system side, let's say it's on the boiler side, it's not a good transfer of heat. So I may have designed my system to condense. I may have a flue gas temperature that I will produce at, say, 140 degrees, but once I add glycol to the system, now the flue gas temperature will be higher because we don't have the same heat transfer properties as water. So that will make flue gas temperatures higher. And this, as you can see, is right out of a boiler install manual. So around here, what we'll see is we'll see a lot of snowmelt systems installed. And a lot of the water temperatures for snowmelt may max out at maybe 120 degrees. Flue gas temperature should be 20 degrees higher, 140. I'm right within that PVC vent type materials temperature range. But 30% glycol is going to be in those systems. So technically, I'm going to be above that temperature range when that boiler is firing. Now, you can argue the point of, well, the boiler wouldn't be firing year round, and you're right, it's for snow melt. And how often does it snow? Well, this winter we had a couple of good storms, so it would have operated. But by code and technically by the boiler manufacturer's install manual, that is the wrong material for that venting, right? So things to be aware of, gentlemen, things to be aware of. I would want to use a product that's a complete system for venting and venting only. This product is not made for use for water or drainage or anything like that. This is made for venting. All right, that's what it's for. And it's got the UL listing 1738. And I believe we're the only manufacturer that has that listing. So here's some definition for you here of the 1738 test program. if you're interested in this, take a screenshot on it. I'm not going to go over every single bit of information that's in here, but what is interesting is on this next slide is you have to pass a leakage test in order to get this approval. All right. There is no leakage test for PVC venting, but in this type of product there is, and we have to pass that. There is no joint sealing compound in our products. We use a gasket, all right, and a locking ring when we put this product together. So there's no curing time needed. The gasket is going to help us handle expansion and contraction, right? Because we heat up the venting and cool it down, it's going to expand and contract. And there's no curing time. That's a big deal. I believe we did get a display boiler because somebody fired off their boiler before the venting that they used, the PVC venting, the glues didn't cure enough and cause an explosion. So we don't have that issue with the Centrotherm product. And strength test of the joint, that's very important too. We have that locking ring so you can be very confident that your joints are not going to come apart. Okay. And we've seen, let me back up one thing. We've seen on the strength test side, I've seen a lot of long PVC runs where the support on that piping is a little questionable. And now I'm relying on that cement to hold that joint together. PVC weighs more than the poly pipe. That could put a lot of excess stress on your joints. So you want to be aware of that, okay? When you're designing your venting, the criteria for your layout is what you see here on the screen. We want to keep it as straight as possible. If we're going to have any buildup of condensate, we want to make sure we have proper drains built into the system and in the right locations. Adequate support for horizontal and vertical runs. So again, you have to follow your install requirements based on boiler manufacturer. Your clearances to combustibles. All right, so depending on the type of material, the size of the material, what kind of a wall we're going through, all right, clearances to combustibles. So we have the lowest clearances, if any clearances, when it comes to combustibles with our poly pipe, okay? We do want to maintain the ability for inspection. We should have at least the first 5 feet of that venting system available for inspection. So if you're running your venting and it's going to disappear quickly once it comes out of the appliance, that's really not to manufacturer spec. You need to be able to see that for maintenance and inspection. Again, we want to make sure we have the least amount of elbows and T's in there. Now, common venting, we will see this often when it comes to commercial installs, when we have multiple boilers installed instead of one boiler. I can't common vent category 1 appliances with a category 4 appliance. That's out of the question, okay? But you also need a material, if I'm going to use common venting, that is approved by the manufacturers in those applications. And the poly pipe by Centrotherm is the only one that's got approval from all of our manufacturers to do these type of installs. What you see on the slide is I'm using common venting practices here to get my exhaust out, and I'm using common venting to bring in my air intake. So take a good look at that picture, because we've all been on a lot of commercial boiler room jobs where we have multiple boilers like this, and they're staging them so they only fire up to the point of where they still will be condensing, then we fire the next boiler and the next boiler as needed. But if each boiler is 2 pipes and they're all vented separately, that means there's 2 penetrations per boiler, either at the roof or at the side wall of that building. That can get really busy. And as we space out the boilers, the runs get longer and longer. I have a picture to show you later on in the presentation. So if you can avoid that and go with common venting, then I have single penetration for air, single penetration for combustion venting. All right. This is interesting. It's in everybody's install manual from the boiler manufacturer, and this is where we see a lot of interesting situations when it comes to venting. So it'll be good up to this point, and then once we make the penetration either at the roof or at the side of the home, all right, the contractor's been very cognizant of windows and doors getting it above snow depth most of the time. Sometimes we see it well below snow depth. But what'll happen is I'll have my exhaust and my air intake right next to each other. And sometimes aesthetically painted and all that stuff, so it looks well, and maybe there's a 45. All right, but what's the problem? They're right next to each other. They're not far enough apart. And that's not good, because what'll happen, it doesn't take a lot of wind speed, under 5 miles an hour, can make that exhaust air, right, come around and get sucked back into the boiler. So if you're going onto a job and there's always a igniter problem, we keep changing igniters, and we'll show up to the job and we'll see multiple igniters on the floor or maybe on the window ledge next to the boiler. Contractors complaining, these igniters stink. It's not the igniters. First thing we do is walk outside to look at the venting, and we can see that we're sucking back in exhaust air. We see this all the time. Or the exhaust now is sticking out and now exhausting maybe onto another appliance. Maybe we're blowing my exhaust on top of my air conditioner. We saw that in one job, and we could see that the condensation was corroding the air conditioner. So gentlemen, we do have to be aware of everything else. So now we've gotten to the point of getting through the structure, where my 2 vents going to be located, follow manufacturer specs guidelines. This is where we see a lot of mistakes. So common mistakes, as you can see here, is not following these instructions, wrong material based on how that appliance is operating. It may be approved, but if we're operating at higher temperatures than the venting material, even though it's approved by the manufacturer, not following their spec, it's wrong. All right. Inaccessibility to inspection. Again, if we're going to have some long runs, do I need some additional drains in there to get rid of condensate so we don't block up the flue? All right. Pitch not being right, too many elbows, as you can see, low spots, and support and seal incorrectly. So what are some advantages that we have with the Poly Pro? All right, well, we have a lot. Obviously, we can handle these high acid produced from the condensate. All right, it's not going to damage our product. All right, if it gets very aggressive, it could damage PVC or CPVC. Our working temperature. So we can operate at that 248, but UL listing gives us 230 as our max. And you can see on PVC and CPVC, 149, 194. Softening temperature at 302 degrees, we start to soften and break down, and it's going to take much lower temperatures on PVC and CPVC to have that happen. When it comes to production, environmentally friendly, but we have an advantage over the other manufacturers. We don't leach any chlorides, and we are fully recyclable. One thing to mention at this point that's not on this chart is right now there are resin shortages out there. And there's going to be shortages when it comes to shipping PVC product. And some of the PVC manufacturers we're starting to hear are not making certain sizes so they can make more of their common sizes to meet demand. We don't have any resin shortages here with the poly pipe that we produce at Centrotherm. It's produced here in Albany, New York, all right? And currently, because of these resin shortages, PVC pricing has gone up to a point where poly pipe, which was always traditionally higher priced than PVC, is now less. So now you have the ability right now, gentlemen, to take advantage of a product that is built for venting. That's all it's for, and your pricing is going to be less than PVC, and it's available. Other big advantages has to do with the weight, especially when we're doing long venting runs. Okay, the weight of that PVC is going to be much higher than CPVC, and that's going to affect my supports. Probably going to need more supports on the PVC side versus what we'll use on poly pipe. So if you've never heard of Centrotherm, they're out of Albany, New York, and they started here in the States in 2009. So they've been in this business for a long time, making top quality product. The other important thing I see here on the screen is the sales support, and especially when it comes to commercial type jobs. If you can sketch out what you want in your venting system, they will produce a bill of materials for you and a drawing. Now, we did a class a couple of weeks back on how to sell. And to me, your value added is a big part of what you bring to that customer. So when you are bidding a job, and I'm going to have a engineered venting system, and I can provide a drawing for it, that's something to talk about, gentlemen. That's a big deal. That's going to make you stand out from the competition. You want to take advantage of that, and Centrotherm is available to help you with that.
Jimbo, while you're on there, let me just break in with a couple of questions for you. One is,
Okay.
we want to know if it's okay to run polypro outside, and another question is it okay to insulate polypropylene after it's installed?
Well, how are we going to insulate it? We can't wrap it with anything, so that's out. All right. If I'm worried about flue gas temperatures condensing, I don't have to with this product because the product can handle that that acidic acid that'll be happening. So it won't damage the venting. We are going to come outside at some point, and we are going to be in. We're going to show you some options where we are using a standard chimney as a chase to use the venting. So I will be surrounded by cold ambient air temperature. It's not going to affect the venting material at all. So you'll be okay in that example. In the catalog, they'll actually show you some UV rated venting. So if you're going to be in a situation where the vent is going to be exposed to a lot of UV rays, we have the material that can handle that also. That's a big plus.
Another one just came in. Can we put a joint together and conceal it in a wall or a ceiling? I don't know the answer to that.
I don't know the answer to that. I would have to refer to the local code official. Okay, I would ask the local code official for that. I don't want to mislead anybody. If I was using plastic venting, as I stated earlier in some of those code references, they said not to use that, but that was based because you're using glues, I believe, for the joints. Since we're not, and we have our locking ring, you may be able to do that, but that is the local code official's job to approve that or not. I would check with him. What else, John?
That's good. And Ron, we'll also dig into that a little bit.
Yeah, we'll check into that. That's a great question. All right. So if you're not familiar with Centrotherm, all right, what does the product actually look like? And let me see. I need the
Mouse back.
mouse back, please. All right. So what does it actually look like? Well, it's this great type of pipe here. You can see.
I know you're going to get into this. Sorry.
Oh, one more
Just while
question.
Actually, going on questions. Can the material be put in a chimney? And I know you're going to review
Yes.
that. So
Yes, yes, it will. I'm going to show you a bunch of options how we can use a chimney as a chase, depending on what your job situation is going to be. So you can see we go from 2 to 12 inch, so we're very capable for commercial work. 2 and 3 inch venting is the most common that you're going to see for residential applications, so we're there. We use these connector rings, all right, for our 2 to 4 inch. It's not recommended that you use it for commercial, but it's something that is a good practice. And there's no glues or primers. We have this gasket here. We have our connecting ring, and that's how we're going to make sure we have a nice positive connection here. Okay. Built-in pitch. What does that mean? Our elbows are not a true 90-degree elbow. They're 87 degrees. So that gives us that 1/4 inch pitch in our venting built in. So that's really pretty cool. All right. You can cut this out in the field to whatever you need to do. All right. And we have all these different options for you when it comes to kits for sidewalls or going through roof, concentric vents, all that kind of stuff. This is very important. We have 100% approval from all the boiler manufacturers for condensing product. Same thing for tank water heaters. Same thing for tankless water heaters. Again, a venting system, not parts and pieces that you'll be grabbing from your supply house, all right, and making up a system on your own, all right? When it comes to furnaces, we have 80% approvals on the OEM side. So if you take a screenshot of this, there is a link on the bottom, the OEM matrix link. So if you want to click on it and see if the appliances that you use most of the time, if they are approved with Centrotherm product, you can see if that's available and then start using that on your installs. So here we're showing you the InnoFlue Flex. So this was a question that just, John brought up. Can I use the chimney for a flex? What you're seeing here on the screen is we can. So if my flue gas temperatures will be below 230 degrees, I can have my flex product going through the chimney. At the bottom, we do have supports like this to make sure that we're gonna have this, the venting material stationary, then we can make our connection to our appliance. This is what it looks like. We have special caps at the top of the chimney, so you can make sure you have a nice sealed connection there. Okay. Concentric venting, if you're not familiar with concentric venting, it's 2 pipes in one. So I have my flue gas in the middle, intake here coming from around it. Concentric venting is nice, especially I'm going through roofs, it's 1 penetration. Same thing on a sidewall, 1 penetration. If my appliance is going to be a 2-pipe appliance, I can still run with 2 pipes and then adapt before I go through either a sidewall or a chimney with this adapter here, and then I just have 1 penetration. We want to take advantage of that, especially, again, multiple boiler installs. If there's going to be 1 complete system, common vent, and we can have a concentric hole going through that wall. All right. Another unique feature that we have is this Blitz intake air pipe. So this is 2, 3, and 4-inch diameter. So here we're showing you on the screen, we're using the existing chimney as my air intake. Just slide this down. It's very flexible, and we're showing it here on the NTI boiler. If you can see some of it here, and I'm using the chimney for air intake because maybe I can't get 2 pipes on the side of the building. If your appliance will operate and they approve, 2 different pressure zones when it comes to venting, here's an option for you here. So now I just have 1 hole on the side for my exhaust, and I'm using the chimney for bringing in my air intake. We have all the accessories you need to do these type of installs. You'll see here on the bottom, we have the 2-pipe low profile, all right? Because sometimes you have to get the piping really far off the house, depending on your application. So here's a low profile 2-vent finishing cap for air intake and air exhaust. Okay, on the side here, you can see that base support at the bottom of the chimney to make sure your venting is going to be supported so you have no problems, and making your connection from that point to your appliance. So out in the field, you guys can cut this pipe. All right, you can, whatever you need, you can cut it to what you want. Once you make the cut, you want to bevel the edge. You want to make a beveled edge, or a chamfer, as we call it. Then we're going to use sealant, or you can use, lubrication or water if you want it. You don't need a lot, just a little bit. Let's see if Jim can do this. All right, I'm going to run this on my gasket here. Very simple, easy to use. I'm going to take my other adapter here. I'm going to have my locking ring. Going to insert with a twist. Insert with a twist. And then I got my locking ring made up. You should see the faces around here. They're laughing at me. But that's how it works. I did it the other day. It was very simple. But that's what we do. All right, so now I have a positive connection here. Hey, you got to have fun. All right, positive connection here. I have no curing time happening here. All right, no curing time. I'm ready to go. Again, the gasket, what is this for? It's going to give me a good seal and help me accept that expansion and contraction that'll happen as I heat up the venting. Okay, I'm good. I use the tablecloth. All right, back to the remote, please. Can I have a, okay, I don't see it down here. So when it comes to support, we have our supporting system. We have these clamps, all right? So depending on how long your venting is going to be, it's every 78 inches. You're going to use one of these clamps on the vertical, 39 inches on the horizontal. It's 3/8 threaded rod that you will buy from your supply house, and that's how you're going to mount this clamping ring. Okay, it's a quick locking system, very easy to use. Loosen up the screw, it opens up, put it around the venting, screw it in there tight, and off you go. All right. So talking about, all right, looking for the remote again. I don't know why. All right, here we go. All right, so built-in pitch, this is what I was referring to earlier. It's not a true 90-degree elbow, it's 87 degrees on that elbow. So that gives us that 1/4 inch pitch when we're talking about 2, 3, and 4 inch piping. It's built in, okay? Then when I get to my 5 up to 12 inch piping, it's built in at 5/8 of an inch pitch per foot on our venting. All right, great feature here. All right, so on this slide here, this is right out of the NTI catalog, product catalog, which we made available for you as a download. This is your typical configurations that you're going to see on a residential install. A lot of 2-pipe installs. I can either have 2 penetrations at the wall, as you can see. All right, again, what we're showing you right here is you want to make sure that we've got our exhaust above our air intake. Very important, not the opposite.
Not the anti- central thumb.
Did I say NTI? I apologize. Centrotherm catalog.
Papa Hooey moment.
It happens. It happens. All right. What we're showing you over here, 2-pipe, and then I'm doing my concentric adapter, and I can have 1 penetration at the roof. So now I have air intake and exhaust coming out the roof here. Again, if your appliance allows 2 different pressure zones, different installs we'll see in this application. And I'm showing you that that type of T here. And again, you can see it's a different color. It's black. That's that UV rated material. So if you feel it could be compromised by excessive UV rays, we have that material for you there. And that's kind of what it looks like here. Actually, T's on the back. We're not going to turn that around. All right. And again, we're showing you here the low profile right on the side here for 2-pipe. All right. I know aesthetics come into play in a lot of installs. It just doesn't look nice, but this is one way to get your 2-pipe. You can get your intake air and your exhaust, and it will look kind of nice. All right. Another application here is with the flex. Again, answering that question of can I use the flex in the chimney? And the answer is yes. What's really interesting here is there's a pre-existing metal vent, and I'm using that as a chase, and I'm running my flex through that, and then having my cap at the top. So that's my exhaust here, air intake on the side. Here we're using the chimney as a chase. There in the bottom, you can see where we have our support for the venting. And we also have the guides on the side. We had a piece here that showed the guides. I think it's unfortunately not here, but we had it. So we have the guides to make sure that the venting stays straight within the chase and it doesn't move around. Okay. And then same thing here where we have 2 appliances going. And if I got enough room in that chimney, I can run 2 flexes in there and get a custom cap made at the top. Right? That's our typical flex installs.
Your sample of the flex install. I don't see.
Yeah, I don't see those either. Trust me, they're there. All right. And here on the commercial side of things, we're showing you the ability to do common venting. So I can do common venting here for my exhaust. All right. And then use that chimney as my chase. All right. Again, I'm using existing pipe here as a chase. And then here's common venting like we showed you earlier for exhaust and common venting for air intake. Nice, clean install, well supported. I don't have to worry about anything with condensation because it's a proper material, easily installed, easily inspected, no curing time. Any questions on that, John?
No, we've been answering them as they're going, Jim. Throw some out to you as they get them.
All right. So the other thing that we have as our advantage, and we want you to take advantage of this, is our design and layout services. If you can sketch a design that you want, you can send it to Centrotherm. They will develop a quote, so you don't have to worry about picking your parts and pieces. So you get a bill of materials. You can either get a 2D schematic or a 3D design drawing, and we'll be able to give you a price quote on this. Again, as a sales guy, I want to stand out. I want to be different than my competitors. If I'm going to be bidding a job with a commercial boiler system especially, and common venting would be in their best interest, show them what you can do, show them what you can provide. All right. Again, it's an approved system, engineered design, take advantage of that, sell it, sell up. All right, so here's some pictures of things that we've seen out there. What you're looking at here is a multiple boiler install in a multifamily dwelling that's not far from here. And it was one of those situations where they were the early adopters of condensing boilers. We're at the 20-year mark. The boilers have started to fail. They're being replaced, and they're just adapting to the existing piping. I believe there's 6 boilers here, so there's 2 pairs of pipe per boiler. We've got a lot of penetrations. We've got long runs, and as you look at the piping, all right, the piping color is starting to change. Here's what I'm trying to bring to your attention. If we put condensing product in and never maintain it, the efficiencies start to go down. As efficiencies go down, flue gas temperatures rise and rise. So if I've had 15, 20 years of really barely any maintenance, that 90 to 95% efficiency has basically disappeared. We could be now in the mid 80s and my flue gas temperatures are much higher. So now that product that you use for venting, which would have been proper in the beginning, is now not proper, and they're adapting new boiler installs to what's already existing. This is a problem, gentlemen. We want to avoid things like this. This next picture, I just don't know what to say. If you take a good look at this, there's just so many things wrong. I don't know what was happening here. I assume this was Mr. Happy Homeowner doing this type of install. I don't even see any glue to keep the piping together, and he's got both air intake and exhaust put together. I don't know what's going on, but obviously we cannot do things like this, okay? And if this particular appliance, and I'm not sure of the model, was non-condensing, the material they're using is not proper. The flue gas temperatures would be too high. What we're showing you here is the beginning of a really good install. There's our NTI boiler. They're using the approved Centrotherm. The NTI boiler install manual states that they want a swing joint at the top so we don't have excessive weight at the top of the boiler where the venting connection is made. So you can see the contractor is accomplishing that on this install. All right. Here's another install here where they're using both Centrotherm for exhaust and air intake. Good pitch. You can see he doesn't have a lot of excessive elbows. He's really close to the side wall there, and he's able to get that install in there. We're not jamming the venting in as a secondary thought. It's a system, and it's an important part of the system. It's the ultimate safety system. So at this point, gentlemen, I've given you everything I got. All right. So a little brief overview. You have the download for the Centrotherm catalog to identify all the parts and pieces for standard residential, flex, commercial, concentric, all in there. Centrotherm has the ability to design venting systems for you. You want to take advantage of that. Again, it's a venting system. That's what it's for. It's not there for water. If anybody has any other questions, please bring them in. We're good? All right. So if you want to view this again, you want to go to hvacinsiders.com, and this will be uploaded on that site. You can go to walesdarby.com, click on our training tab. It'll also bring you to the HVA Insiders site, and you can see this video a second time. Any of the previous classes that we've done that are recorded, and they're on HVAC Insiders, and you can view them there too. And if you want to see what our next schedule of classes are going to be, you will find it there. So either walesdarby.com, click on the training tab, or go to HVAC Insiders, and you can see everything that we've done. So if there are no further questions, I really appreciate everybody's time, and thank you for joining us. Next week, we're doing tankless water heater, correct? And that is going to be a wild class, so tune in for that. You want to learn everything about tankless water heaters. Thank you very much, and have an awesome day.